This is the second video for solving rational equations, and we had left off not having finished the one on the bottom, but I needed a second to set it up, and the video was getting long, so I figured let's swap and start new here. So I got a 6x over x plus 5, a minus 30 over x minus 5, and then an equation on the other side. And it starts out rather nicely in the sense that I've got an x plus 5x minus 5 on one side, and an x squared minus 25 on the other. So x squared minus 25 factors as x minus 5x plus 5. So I rewrote the problem up here so it'll give us a little bit more space to solve it, because it looks like with that x minus 5x plus 5 and the x squared minus 25, it could be a nice easy problem to solve. We'll see what we get. All right, so it looks like if I multiply both sides by x plus 5x minus 5, that'll clear out some fractions. So x plus 5x minus 5 to the second term. X plus 5x minus 5 is just x squared minus 25. So when I do that to the third term, there we go. So the x plus 5's cancel, and I'm left with a 6x and an x minus 5. The second piece, the x minus 5's cancel. Don't lose the negative sign, so I get negative 30 times x plus 5. On the other side, the x squared minus 25's cancel completely, and I get a 6x squared plus 150. All right, let's distribute. 6x times x is 6x squared minus 30 times x minus 30 times x minus 150. On the other side, a 6x squared plus 150. Now you notice a 6x squared's on both sides, so if I subtract a 6x squared from both sides, they'll go away. Negative 30x minus 30x is negative 60x. On the other side, I get 150. So add a 150 to both sides, and I get negative 60x equals 300. Divide both sides by negative 60. And I get x equals negative 5. Now, with an x equals negative 5, I've got a problem. If I go back into my original equation and I put a negative 5 in here for x, or even if I put a negative 5 in here for x, I'm going to get something that is undefined. Just to show you what happens when I get these things that are undefined, I went and I graphed it on Desmos just so that you can see what these graphs are. So the left side of the equation was a 6x over x plus 5 minus 30 over x plus 5. So we would get a solution when the left and the right side cross each other. So the left side of the equation is red, the right side of the equation is blue. Where do they intersect? Well, it's a funky looking graph, right? It's got a whole bunch of different pieces to it. There's vertical asymptotes, there's horizontal asymptotes. But what's happening at x equals negative 5? Right? Negative 5, there's negative 2, negative 4, here's negative 5. The graphs get very close to negative 5, but they never, and they start writing almost on top of each other, but they never actually touch x equals negative 5. So we've got, here's negative 5.4, here's negative 5.3, as you can see by the x value when I highlight it, right? The x values are close to negative 5, but they never actually hit negative 5. But yet when we solved it, we said the solution to the problem was x equals negative 5, and the graph never touches it. So that's what's happening in some of these cases where you're getting answers and you come up with a number, right? Negative 5 is a number, but it simply doesn't work as a solution to the problem because you're trying to find when the two sides of the equations are equal to each other, and they're not. All right, let's take a look at the next part of this, which is solving for a variable. Some of this you've already done before. In fact, earlier in this course, we were trying to solve for y in terms of x in order to get the equation in y equals mx plus b form so we could identify slope and y-intercept more easily. So suppose you started with a 4x plus 2y equals 8. You just do common operations on both sides. So subtract a 4x from both sides, divide by 2. You've solved 4x plus 2y equals 8. Solved it for y, meaning you got y on one side, everything else on the other side. Why would we want to do this? Well, suppose we had an equation like this. Maybe you recognize this as the formula for the circumference of a circle, and you want to find the formula as radius in terms of all the other variables. So solve c equals 2 pi r for r. So you're going to solve one formula in terms of a variable. So what do? We undo operations. We want to get r by itself. 2 pi and r are all multiplied. So you undo multiplication by division. So in this case, if we divide both sides by 2 pi, now the 2's cancel, the pi's cancel. So on the left side, I get c over 2 pi. On the right side, I get just r. So I've solved the circumference formula for r. Now I can get the radius based on the circumference in 2 pi. All right, look at this one. This is another geometry formula. This comes from the geometry formula. Well, I won't tell you. We'll figure it out in a second. It says h equals 2a over capital B plus lowercase b, and I want to solve for a. So I've got to sort of work my way backwards until I get to this a all by itself. First thing I can think of is, let's get rid of the b plus b's, right? That's the denominator. So if I multiply both sides by b plus b, then I get h times b plus b. On the other side, I get 2a. Divide both sides by 2. Now, you can write this as h over 2 times b plus b. That's the equivalent. This is actually the area formula for a trapezoid. Remember, trapezoids have different base lengths. And so I stole this from the textbook. They use a capital B and a lowercase b. When I use area of trapezoid formulas, I usually call them like base 1 and base 2. But they elected to do that, so I figured I'd show you one that looks like that. All right, one more. This one's a little bit different. This is a pool filling problem. So a pump can fill a swimming pool in 6 hours. Another one can fill the pool in 9 hours. How long will it take the pumps to fill the pool working together? So the question is, how much of the pool is filled each hour by each pump? So pump number 1 can fill the swimming pool in 6 hours. So each hour it fills in 1/6 of the pool per hour, right? So if it takes 6 hours, it fills up a sixth plus a sixth plus a sixth, and it does that 6 times till the whole pool is filled. Pump number 2, if it's a little bit slower, not as much power, it fills the pool in 9 hours. So it fills in 1/9 of the pool per hour, right? 1/9 plus 1/9 plus 1/9 9 times will fill up the whole pool. So the question is, what if I put both pumps in there to fill up the pool? How long will it take me to fill up the whole pool? Well, here's the other key. I have one pool that I need filled. So let's let h be the number of hours. Well, pump number 1 fills in 1/6 of the pool per hour. This second pump fills in 1/9 of the pool per hour. Remember, we said I have one pool that I'm trying to fill. All right, so if the first pump was the only pump, h would be 6. If the second pump was the only pump, h would be 9. Right? 9 over 9 is 1, 6 over 6 is 1, but it's not. They're working together. Oh, how beautiful. So look at my denominators. I got a 6 and a 9. Yeah, I could do a denominator of 54, but I bet you the least common multiple is 18. Okay, so if I multiply this side by 18, don't forget to multiply the other side by 18 or you'll get a ridiculous answer. Or one that makes absolutely no sense, like a negative number of hours. So 18 divided by 6 is 3, so I get 3h. 18 divided by 9 is 2, so I get 2h. On the other side, 18 times 1 is 18. Right? 3h plus 2h is 5h. So if 5h is 18, divide both sides by 5. And I get h equals 18/5. 18/5 of a what? 18/5 of an hour, right? We said at the beginning, h was the number of hours. So 18/5 is 3 3/5. Now, if you want a little extra credit here, how much is 3/5 of an hour? Well, an hour is 60 minutes. So 3/5 of an hour is 3/5 of 60 minutes. Well, 60 divided by 5 is 12. 12 times 3 is 36. So 36 minutes. So we could also say 3 hours and 36 minutes. So with the two pools pumping together, it's going to take less time than either one. So it's not going to take 6 hours. It's not going to take 9 hours. It's going to take 3 hours and 36 minutes until that pool is filled. That's it.